So let's see. Just helpful things before we start that are going to go for every factoring problem that we do. And I think the biggest one is the very first line here. It'll come up a lot. You always want to look for a greatest common factor before you start. Like that is the first factoring method we're going to do, but every other problem we do, we have to ask ourselves, is there a greatest common factor? The rest of these, we'll get to them. There's just some notices about like if there's 2 terms or 3 terms. Once we're done with all the different factoring methods on Wednesday, we'll kind of organize like, okay, how do I know what method to use? So we'll skip that. But the bottom part here, you can always check your answer by foiling or distributing your work. So going backwards. Factoring is the opposite of FOIL or multiply. So we can always do that. All right, let's start with the easy one, greatest common factor. If I have 15x squared and 10x, what do those 2 terms have in common? Shout it out. 5. What else? 5x. Now, I like to write it out by dividing 5x out of both, just to remind ourselves, because some of these will get a little bit more complicated. You don't have to. You can skip to just writing 5x in front. It will not bother me. I'm just going to write divided by 5x underneath both, so that if you need to, you can see it. 15x squared divided by 5x is 3x, and 10x divided by 5x? -2. And that's the answer. Now, again, if you wanted to check your work, if you had time and you were being careful, you would distribute here. 5x and 3x is 15x squared. 5x times -2 is -10x. And then you know you had the right answer. All right, number 2, 45m squared plus 80m. What do they have in common? 5. Okay, 5 goes into both. How many m's? 1. So if they both have an m, you take the m with the lower exponent, which is just a 1 here. So I can pull a 5m out of both. And then what's 45m squared divided by 5m? 9m. Okay, 80m divided by 5. Yeah, I think it's 16. And that's it. Those ones are pretty simple. Are there 2 more? I don't remember. Yes, there are 2 more. I guess I put my sheet over here to cheat off of. All right. These ones a little bit more with some different letters here. All right. What do they all have in common? Start with the numbers. 12, 18, and 30. What number do all those have in common? 6. Okay, so this is 6. What else do all those terms have in common? In x, how many x's? Just 1. Okay. Why do they not have, why can I not pull a y out? Yeah, because the 30x doesn't have a y on it. So your greatest common factor is just 6x. Then you can divide that out of every term. What's left from the first term when I divide 6x out of it? 2x squared, y squared. So there's still a y inside. What about the next term? What does that simplify to be? -3x y squared and plus 5. There you go. Okay. So a little bit more complicated looking, but really not that more complicated of a problem. All right, and then number 4. Oh, what do those all have in common? An x, they all have 1 x and 1 y. So if you want to write x, y underneath, you can. Otherwise, just put it in front. All right. What's the first term when you divide by x, y? These y's cancel. So just 2x squared. Okay. Let's see. The next one. Looks like the y's cancel again. So you're left with minus x. This one, the x's go away, so you'll have plus 5y, and the x's go away here, plus y squared. That's it. Easy, greatest common factor. By itself is not hard, especially when I'm isolating and saying, pull out the greatest common factor. Skip the next couple. You're going to do those practice on your own later. We're going to jump down to the bottom and review grouping. Okay, now, grouping is the method that GCF, what we did first, can happen anytime you factor any problem, no matter how many terms there are. 2, 3, 4, 5. Grouping is specific. This is only used when there are 4 terms. Okay, so there have to be 4 terms separated by plus and minus like I have here. The way I like to write it is as follows. I like to put parentheses around the first 2 terms, and then I like to put parentheses around the second 2. Some teachers do brackets underneath like this. It's the same thing. I just like to do parentheses. The second one, I like to put parentheses around the plus or minus sign that's there as well. Now, here's what you do when you group. After you've grouped them, look at the first group on the left. Is there a greatest common factor between those 2 terms? Yeah, what is it? X squared. So you're going to pull an x squared, factor that out of just the left side. When I factor x squared out of x cubed, what do I have? X plus 2. Now, leave that guy alone for a little bit. I'm going to look at the right group. I'm going to pull a GCF out. Now, if the third term is negative, that means my GCF is going to be negative. So what negative number can I pull out of both here? Negative 3. So I put that in front of my set of parentheses. It's my second GCF. And what's negative 3 divided by negative 3? 1x, so just x. And then negative 6 divided by negative 3? Plus 2. Now, if you remember grouping, why is it what I have written there a good thing? The x plus 2's are the same. That's always your goal. If you're doing grouping, which we're going to use in another method here tomorrow, those parentheses have to be the same. If they're not, you made a mistake somewhere. Bless you. Does anyone remember what comes next? Shout it out. Tell me what to do. Yeah, these GCFs right here go in a set of parentheses together. They become a binomial. Those GCFs technically factor out. And then what's the other parenthesis for your answer? X plus 2. This is it. This is your answer. Now, if you don't believe me, we could check by double distributed. Okay? But that would be it. You remember doing that? Let's look at the next one really quick. Example 2. All right. Same idea. We're going to put parentheses around the first 2 terms and around the last 2. What's the GCF on the left? 2x squared. They both have 2x squared. So if I pull a 2x squared out, what is left inside my parentheses? 5x minus 1. If the GCF is actually the term, you can't just ignore it. You have to put a placeholder of a 1 there. Okay, what's the GCF on the second set of parentheses? Not 5. Negative 5. The term is negative, so you pull out a negative 5. And when I pull out negative 5, what's left in the parentheses? 5x minus 1. Again, I want 5 divided by negative 5 is negative 1. The parentheses are the same. That's a good thing. So how do I write my final answer? Yep. Got it. Good. Good with grouping? We're almost done. Flip the page over. Skip the practice. There's going to be a couple for you to do in a few minutes here. Trinomials. Nothing fancy about these trinomials today. Now, when I did trinomials, this I inherited this x thing. I used to do that. I kind of do a little bit differently now. Have any of you seen that x thing before for factoring? Okay, so you know what it is. So if I don't do it later, you'll be okay. When you factor a trinomial, remember, we're only factoring today plain old x squares that have an invisible 1 in front of them. You're looking for 2 numbers that multiply to be the last number, 6, and add to be the middle number of negative 5. So when they do the x here, I usually just write like 2 numbers that multiply to 6 and then make like a little tree if I need to. But you can do the x if you want, whatever works for you. What numbers can you think of that multiply to 6 and add to negative 5? Shout them out. Negative 3, negative 2. So a lot of people will write them like this in the x, but you would put them right here. Now the trick about trinomials that make these fast is that because we're multiplying to just an x squared as our first term, your binomials here, the parentheses, each only need to have an x. Tomorrow we'll do ones that have like 2x squared or 10x squared out in front, and they'll be a little bit different. The way you would check these, just like we talked about, and reviewing what we did from our summer packet, you would multiply. I'll just check this one. X times x is x squared, minus 2x, minus 3x, I forgot the x, plus 6. And if you combine those like terms, you would see that you got the right answer. Remember that one, okay? Let's try the next one here. Two numbers that multiply to negative 36 and add to 5. 9 and negative 4, yeah. So x plus 9, x minus 4. Let's do just a couple more, and then I'll leave you alone. X cubed plus 7x squared plus 10x. Oh, we haven't seen one like this, and I haven't asked you this question a lot yet. What do I have to do first? GCF. What do they have as a GCF? X. So I'm going to pull an x out in front. So this one is 2 factoring methods. I divide an x out, and what's left inside the parentheses when I get rid of that x? X squared plus 10. So now I'm just factoring a trinomial. Nothing fancy here. I know my answer is going to have that GCF of x in front, and then I'm going to have 2 sets of parentheses. So I need to find 2 numbers that multiply to 10 and add to 7. 5 and 2. So I'm going to have one parenthesis that is x plus 5, and one that is x minus 2. And that's it. Now if you wanted to check your work again, you would just FOIL or multiply. Yep, it would be plus 2. Thank you. I was just testing you. Alright, last one. X squared minus 17x plus 60. 2 numbers that multiply to 60 and add to negative 17.
23.
What is it?
23.
Okay, if I did 20 and 3, I would need which one to be negative?
Negative.
Ooh, because if I had negative 20 and positive 3, that would multiply to be negative 60. That's not going to work. And then if I did positive 20 and negative 3, that would be positive 17. What else? Yeah, negative 5 and negative 12, I think, work. Those multiply to be positive, and then we'll give you negative 17. Here's some tricks with signs for if it helps you. If you're multiplying to be a positive number, you either need 2 positives, right? Positive times a positive is a positive, or 2 negatives, because 2 negatives multiply to give you a positive. The way you'll know the difference is looking at this middle term. If it's negative, you want 2 negatives. Right? If this was a plus sign, like this one over here, you want 2 positives. All right, any questions? Any concerns? You're thinking, okay, that wasn't too bad. Thought this was honors. That's okay. We're easing you in. That's it. So here's what we're going to do for the rest of the day. You have 6 problems here for method 3. You have 2 grouping problems up here, and then 2 GCF problems. When you're done with that,